Assalamualaikum warahmatullahi wabarakatuh. Today I would like to make a presentation about chemistry co-assignments. And my name is Muhammad Nizar Haikal and my other teammates is Muhammad Aziz Rizal. So we would like to discuss about hydrocarbon. Question 3 this is the question of our group, which is question number 3 of task A. Uh, consists 5 structure isomer JKLMN by using a molecular formula C4H8. So in this slide, I would like to say that there are 5 isomers in CH4CH8, which is 2-methylpropene, 2-butene, butene, methylcyclopropene, and cyclobutene. As I mentioned, 2-methylpropene is J, 2-butene is L, butene is K, methylcyclopropane is N, and cyclobutene is M. For the boiling point, in the ascending order, K is lower than L but higher than J. What is K? K is butene. So butene is lower than 2-butene but higher than 2-methylpropene. Why? It is because butene has higher boiling point compared to 2-methylpropene. It is because the dispersion force between 2-methylpropene, which has a branch and a small surface area, is weaker than butene. So butene has a higher boiling point than 2-methylpropene because the molecules are longer. As we know, the structure of the butene is longer than 2-methylpropene. So butene has a larger surface area than 2-methylpropene that it will set up a bigger temporary dipoles. So butene molecules can tie closer together than the shorter and fatter 2-methylpropene molecules. So and uh, 2-butene has higher boiling point than butene. The double bond occur at the second carbon, and the bond will be stronger and not easy to be break. As we know, 2-butene had a highest boiling point than butene and 2-cyclopropene.
Two isomers that give optically active product. For the first one, 2-butene. Here we will use the electrophilic addition mechanism. For the first step, addition of an electrophile. For the starting material, which is 2-butene, it has the double bond in the molecule. So here will be the nucleophilic site and here will be the electrophile. The double bond or pi bonds will attract the hydrogen from the electrophile, and this reaction follow Markov-Nikov rule. The hydrogen from the electrophile will attach to the carbon double bond, which has more number of hydrogen atoms. Here, two carbon here have same number of hydrogen atoms, so the hydrogen from the electrophile can attach to any carbon, and the product will be like this, and it will form one carbocation, and but the byproduct is bromide ions. This reaction rate is low. For the second step, formation of product from the carbocation, the bromide ions will attract to the carbocation, and the final product will be the 2-bromo-butane. This reaction rate is fast. For the second one, 2-methylpropene. 2-methylpropene has double bond in it, so it will be the nucleophilic site, and hydrogen bromide will be the electrophile. The double bond will attract the hydrogen from the electrophile, and this reaction follow Markov-Nikov rule. So the hydrogen from the electrophile will attach to the first carbon, because first carbon has 2 hydrogen atom attached to it, as we can see here, and the second carbon doesn't have any hydrogen atom attached to it. So the product it will form one carbocation in the molecules, and the byproduct is bromide ions. For the second step, formation of product from the carbocation, the bromide ion will attach to the carbocation, and the final product will be 2-bromo 2-methyl propane, and this reaction rate is fast. By using Bayes test for J 2-methyl propane, the observation is purple color turn to colorless and brown precipitate occur. 2-methyl propane will react with potassium permanganate in cold dilute basic solution, and it will form 2-methyl propan 1,2-diol, and the brown precipitate of MnO2 will be observed. For M, which is cyclobutane, when cyclobutane react with potassium permanganate, it will has no reaction because cyclobutane is alkane and it is a saturated compound. The observation is purple color does not change. And for the last one, structure of the isomer C4H8 that shows geometrical isomerism, which are cis-2-butene and trans-2-butene.
Okay, for the task B, the type of plant that mentioned in Quran. So our group has decided to choose olive. For the Quranic version, Allah has mentioned the olive tree in Surah An-Nur verse 35, which is Allah said that Allah is the light of the heaven and the earth. His light is like a niche in which there is a lamp. The lamp is in a crystal. The crystal is like a shining star, lit from the oil of a blessed olive tree, located neither to the east nor the west, whose oil who almost glow, even without being touched by fire, light upon light. Allah guides whoever He will to His light, and Allah sets forth parables for humanity, for Allah has perfect knowledge of all things. Okay, for the active component of the olive oil is include oleic acid, phenolic constituents, and squalene. The main phenolic including hydroxytyrosol, tyrosol, and oleuropein, which occur in highest level in a virgin olive oil and have demonstrated antioxidant activity. Okay, for the organic structure of olive, as we know, oleic acid is omega-9 fatty acid, which has uh, carbon 88, hydrogen 164, and oxygen 10. Which in simple form, I can say that the organic structure of olive is C8H17, CH double bond CH, and CH27 COOH. For composition of olive oil is composed mainly of triacylglycerol or triglyceride or fat, and contains small quantities of free fatty acid FFA, glycerol, phosphatides, pigment, flavor compounds, sterols, and microscopic bite of olive. As we know, triacylglycerols are the major energy reserve for plants and animals.
Benefits of olive. Olives are very high in vitamin E and other powerful antioxidants. Studies show that they are good for the heart and may protect against osteoporosis and cancer. The healthy fats in olives are extracted to produce olive oil, one of the key components of the incredibly healthy Mediterranean diet. The preparation of oleic acid. Here is the chemical reaction for the preparation of oleic acid. Now I will explain the preparation of oleic acid. Firstly, ethyl sodium and heptyl malonate will react with 9-carbethocyanonyl chloride to produce 10-cathostearic acid. In condition, ether cold dilute base, boiling dilute sulfuric acid, boiling dilute sodium hydroxide. For the second one, 10-cathostearic acid will undergo reduction process and produce hydroxystearic acid. Then it will be converted to iodostearic acid in potassium hydroxide solution. Finally, the oleic acid will be produced. Okay, that's all for our group. Thank you.